Topic 8-6. This can be referenced with our Holt textbook, Chapter 7, Section 5, pages 488 through 494. When using proportional relationships, that's used to help find distances that can't be measured directly. So we're going to go through some examples of indirect measurements to scale things that are much bigger, find out the size. Similar polygons. Review again that polygons have the same shape but different size. And there are three ways to show the triangles are similar. We would previously shown that through angle-angle similarity, side-angle-side, and side-side-side. Similar triangles can be used in indirect measurement. So here we've got a triangle inside of this other triangle, larger triangle, but by angle-angle, this angle is shared by both triangles, and angle-angle on the smaller triangle, and this 90-degree angle along with the same one shows that they're similar. So because they're similar, we're going to figure out the scale factor. The long leg that shares the same angle-angle side, 10 to 22, reduces to 5/11. So using that scale, we can compare the other side, the side that's the length of 5 and x. So 5 is to 11 as 5 is to x. Solve and you'd get that x is 11. Okay, so it's important to find the scale factor first. Let's look at another example. This one can be found by, let's see if this one's the same angle-angle. If these are both parallel lines, then this angle and this angle are congruent by corresponding, so we know that those are congruent. This is congruent to itself, so that's considered reflexive. So this too can be measured by angle similarity to show congruencies, that these triangles are congruent. I'm sorry, similar. Okay, so again, we need to find the scale factor. Well, you know one of the sides that is common proportion to the other side is a 3 to 6. Well, 3 to 6 reduces to 1/2. So 1/2 is our scale factor. And we're going to take the same comparison. Small triangle to the larger triangle. The small triangle's common side is 8 to the x. So make sure you've got your proportion set up correctly. Cross products would give you x is equal to 16. Okay, the last example is, notice this tree makes the triangle here, forms that triangle by drawing a straight line, and then this similar to this triangle because we're saying that this is due north, parallel lines. So because those are parallel and they share a common angle, they also have this angle in common as perpendicular. So this would be similar to example 1. So finding the scale factor first, take the small triangle's length to the large triangle's length. 24 to 56 reduces to 3/7, make that a 5. And 3/7 compared to 21 over x. Now notice the x is at the bottom this time because you're looking for, you've got to keep sameness to sameness. The long length was originally my 56 that reduced to 7, and the x is what's unknown. The similarities have to stay in the same position. Cross products give you 3x is equal to 147, x being 49 meters. Okay, example 4. When Stephanie stands 2 feet from the lamppost, her shadow is 3 feet long. If Stephanie's 5 feet tall, how tall is the lamppost? Well, drawing the picture of this helps. Shadows are what's created on the ground, so we measured that as 3 feet. if she's standing 2 feet from the wall, the lamppost is this distance from here to here is what we're trying to solve for. So we have to be careful here when we're doing our scale factor. It's this small length here to the large length of the large triangle. That's going to be 5. So 3 to 5 is the scale. So 3 is to the complete length of 5, as 5 is to the length of the lamppost. Cross products is going to give you 8 1/3 feet. And I showed it with just one asterisk instead of writing out feet. You could do it either way. Example 5. Charlie walks away from a tree along the shadow until his head is in line with the top of the tree's shadow. He's standing 15 feet from the base of the tree and 6 feet from the end of the shadow. So if this is the shadow that he would create and he's 6 feet away from it, 15 feet from the tree, I know mine's not necessarily to scale, but still this is a representation of what this would look like. It says the end of the shadow. Charlie's 5 feet tall, so that's going to be his height. So what's the height of the tree? Assuming these are parallel lines, you can form a similarity by angle-angle similarity again. The small triangle is the 5, includes the 5, 6. The large triangle includes the unknown and 21, because you don't take just 15, you take the distance from here to here. So 6 to 21 reduces to 2/7, representing the 5 is to x is your other similar proportions. Cross products gives you 17.5 feet. Again, make sure you copy these down for future reference when you're working through the problems. Example 6. A mirror is on the ground 8 feet from Ricky. So here's Ricky, and I'm going to draw it this direction, and 19 feet from the pole. So I put it in the center of the person and the pole. And he can see the top of the pole in the mirror. So it's reflecting off of the mirror, and then he sees it going up to here. He's 6 feet tall, and they want to know how tall the pole is. Notice how different this is than the previous examples in that I've drawn it on the outside, but you still can show similar triangle to similar triangle because these measurements create 90-degree angles, his height to the ground, and shadow to shadow. So for proportion to proportion, we're looking at the 6 is to the unknown as the 8 is to the 19. Remember, this time you were given the full length, whereas up here you had to add them together. So again, I kept my small triangles proportions together this direction, and same thing here. The larger ones to this one. Okay, cross products gives you 8x is equal to 114, and x is 14.25 feet. And that concludes topic 8.6.